Chapter 1 will be organizing data. What we're going to do here is take a large set of data and basically put it into kind of a table type format or something called a distribution. So you can see right here, right away, three types of distributions are labeled. Categorical distribution, grouped frequency distribution, and an ungrouped. Quick explanation, categories are just as the name implies, we're breaking our data down into categories. So for example, we might group or separate information out based on grade level, sophomores, juniors, seniors. We might break something down into Democrat or to political parties, Democrat, Republican, Independent, things like that. Colors, red, white, blue, green, those are categories. A lot of our work is going to be centered around the grouped and ungrouped, especially the grouped. Grouped, we're going to take a numerical set of data, both in ungrouped and ungrouped, or grouped and ungrouped, and make a table format. We're going to put our numbers into different groups of numbers. So for example, maybe we took an ACT test and we could say some scores are between 10 and 14, some are between 15 and 19, some between 20 and 24, and so forth, between 25 and 29. Let's go with 30 to 34. And even though 36 is the perfect score, we'll go 35 to 39. Okay, so we'd be putting our scores for each individual person into one of these grouped categories here, and that's going to separate our information out into a table format. Ungrouped just means that each of these numbers, each test score by itself would be a class. So we might have a score of 19, a score of 20, a score of 21, 22, and so on. So we're going to break our data down into that format. With a group distribution or any of our distributions, we'll have these five categories or these five columns listed. Class limits, or I just put up there the 10 to 14, the 15 to 19, something like that. Those will be our classes. Boundaries have one more decimal place in a 5. So for these two classes, I'd have 9.5 to 14.5, and I have 14.5 to 19.5. What our class boundaries show is simply our data being continuous. It plugs in those decimal values, decimal gaps in between. It's also somewhat useful in the graphing process we'll take a look at later. Our tally marks will put each of our scores into one of those classes. Our frequency will come from the tally, so if we have 5 tally marks, we'll have a frequency of 5, and a cumulative frequency is a running total there on the right-hand side, kind of like you keep on your checkbook where you'll add as you slide down there. Class limits have the same place value of data, so our test scores for ACT could be whole numbers as we see here. Our class boundaries, just talked about that. They have one more decimal place, an N and a 5. Some guidelines to follow. Pretty broad spectrum here. There should be between 5 and 20 classes. There's no set number you have to have. Unless your data set is a super large set of numbers, I'm going to say probably between 6 and 10 is probably ideal. If you get to be too many, 20 classes is going to be a lot unless you have a whole bunch of numbers. Class width should be an odd number, so if we can find the class width to be an odd number, that allows us to say our midpoint is going to have the same place value. So I'm going to go back up to my 10 to 14 and my 15 to 19. Class bound, or the widths, are found by subtracting one lower limit from the next. So we subtract these two numbers. It's not 14 minus 10, but it's 15 minus 10. So I have a class width of 5. And when you notice up here, what that tells me or gives me is the midpoint between 10 and 14 is 12. Midpoint has the same place value. Midpoint between 15 and 19 is 17. Whereas, say I had a class from 10 to 15, then I go 16 to 21, now my midpoint is 12.5, doesn't have the same place value as the raw data, so in other words, I can't get a score of 12.5 on the ACT test, got either a 12 or a 13. Okay, so there's a reason we would like our class width to be an odd number. Class midpoint, we just said 10 plus 14, or 14 plus 10 is 24 divided by 2 gives us 12, so we can add the upper and lower together and divide by 2. These are rules that must be followed. The classes must be mutually exclusive, so I can't go from 10 to 14, then from 14 to 19, because where do I put the score of 14 at? Do I put it here or do I put it here? So they must be mutually exclusive. They can't have an overlap from one category to the next. They must be continuous. So even if I don't have a score of 15 in my data set, I can't skip 15 and go 16 to 19. I've skipped 15, so my classes must be continuous. They have to have all the numbers. They must be exhaustive, so it has to include every number in my data set. ACT score goes up to 36. You know, if somebody scored poorly, worse than 10, we'd have to go down and go 6 to 9 or something like that. Have to have a class for all of our possible numbers. And our classes must be equal in width. So notice I can't go a class width here of 5 and then a class width here of 4. Okay, they must be the same all the way through there. So a couple of rules, actually 4 rules that we have to follow when setting up our distribution. And finally, as we construct a group distribution, determine our number of classes. For our purposes, the book will probably tell us, and notice up above it says between 5 and 20 classes. Again, we're going to stay somewhere smaller than that, somewhere between probably 5 and 10. Find the highest and lowest value. That will give us the range. Find the width by dividing the range by the number of classes and rounding up. Okay, there's a key point right there. Always round that up. And again, we'd like that to be an odd number if possible. Select a starting point, usually the lowest number, but it can also be any convenient number lower than that number. Add the width to get the lower limits, fill in the upper limits, find the boundaries, tally the data, find the numerical frequencies, and find the cumulative frequencies. That whole process will probably make more sense as we go through it, so that's what we're going to do right away right here is look at this group of numbers. We have the record high temperatures for each of the 50 states listed here, so we have 50 total numbers here. We're going to break that into our distribution, into our table format. So the first thing I do is search through here and find the highest number, which is 134, and the lowest number, which is somewhere in here. We have 100. So I'm going to take 134 minus 100 to find my range. I want to find 7 classes, so I take that range and divide it by 7. And 34 divided by 7 is going to give me probably 4.8 or 4.9. We always round that up to the next whole number. Number 5, that will be our class width. That also works out well because our class width is an odd number. 5 is an odd number. So down here, we start out, we'll create our classes. And I'll start with my lowest temperature. Now here's kind of a tricky part that people mess up on is our class width is 5, so we fill out each of our lower class limits first. So 100, 105, 110, 115, 120, 125, and 130. 1, 2, 3, 4, 5, 6, 7. So I have 7 classes. Now I go back in and fill in my upper limits. So if my second class starts at 105, my first one ends at 104, 109, 114, 119, 124, 129, and 134. Quick little side note here, this is just a coincidence. Typically our distribution is not going to end on our highest number. Okay, as long as this highest number falls in this last category, then we're fine. Okay, so just make sure you make note of that. That's just kind of a coincidence that it works out because this divided out to be almost so close to being a whole number of 5 that it worked out that way. Our next column here is something called the class boundaries. The class boundaries have one more decimal place and end of 5. So I go from 99.5 to 104.5. I go from 104.5 to 109.5. And we'll just fill in each of these as we go down here. Okay, so again, our boundaries have one more decimal place and end of 5. Again, it essentially plugs in those decimal gaps in between 104 and 105 to show our data being continuous. Probably more importantly, it is used in the graphing process, makes our graphs a little bit smoother here in our next section. So now all we're going to do is take each of these numbers and place them into their different classes. So 112 goes here, 100 goes here, and so on. So I'll just take a quick minute, I hope, and plug those in. My table's not real great down here, so it might be a little bit of a struggle to get those in the right spot. So hopefully I take my time and do this the correct way. But you can just follow along as I plug those into each of their different classes. Okay, so hopefully I have those all in the correct classes now. From here, all we do is put in a frequency column. The frequency is just our total number of tallies. So you can see I have 2 tally marks there. I have 8 there. I have 18. I have 13. I have 7, 1, and 1. And our last column is called a cumulative frequency column. That's also going to serve as a check to make sure we have everything correct because it's just a running total. I started out with 2. 2 plus 8 is 10. 10 plus 18 is 28. 28 plus 13 is 41. 41 plus 47 is 48. Plus 1 is 49. And plus 1 is 50. So we have all 50 states listed in there. So there's our table format or a grouped distribution for our set of data, for in this case for our record high temperatures in the 50 states. Okay. Now again, it doesn't have to look exactly like this. Maybe we started at 99 or something like that, but it should look very similar. We do want our class width, if at all possible, from here to here to be an odd number, which it is. It goes from 5, so notice there are 5 all the way through there. And then we've separated our data out into each of these different classes. Okay, so one more time here. We have the data for the number of miles per gallon at 30 selected SUVs obtained in the city of driving. I'm going to add right in here, we're going to construct an ungrouped frequency distribution. So as we do this, we'll set up our classes, but each of the numbers here are going to be a class by themselves. So it looks like I have a low of 12 and a high of 19. So I'm going to list each of those as a class by itself: 12, 13, 14, 15, 16, 17, 18, and 19. Anytime that we have numbers as part of our classes, we'll have boundaries. Now, as a side note, if this were red, white, blue, green, we wouldn't have boundaries because you can't add and subtract 0.5 from a color, so from a category, so we won't have boundaries for categorical distributions. But here for 12, our boundary is 11.5 to 12.5. 12.5 to 13.5, and so on. So I'll fill in each of these, zipping down through here. And as we finish this off, those boundaries again, probably used in the graphing process more than anything. Our tally marks, again, those are somewhat kind of optional, but I have 1, 2, 3, 4, 5, 6. Looks like I have 6 in the 12 category. Oh, 13. Do I not have a 13? There's a 13. Just the one. Okay, 14, 1, 2, 3. So I'll put 3 tally marks there. 15, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 16, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 17s, 1, 1, just 1. 18s, 1, 2, 3. And I missed a 17, so let's go back up here. And 19s, there's 119 there, and that looks like it might be it. So hopefully our other columns will make sure I have all those numbers in there. 6, 1, 3, 6, 8, 2, 3, and 1. And the setup of these is not always has to be these numbers, but the cumulative frequency helps us with our graphing the number 1 in our next section, but also serves as our check here. So 6, 7, 10, 16, 24, 26, 29, and we have all 30 in there. So there is an example of an ungrouped distribution. The one we did not do is a categorical. Again, categories red, white, blue, green. We wouldn't have the boundaries. Everything else would look very, very similar. We just break those numbers or those categories down into our different classes and put our tally marks in there along with our frequencies. So there's our look at distributions, grouped, ungrouped, and categorical.